All right, so we have number 4. This one is aluminum and copper 2 chloride reacting to produce aluminum chloride and copper. So you did this in your in class, by the way, if you were there and you poured that a solution onto aluminum chloride, we saw the reaction happen. But here's the thing, okay? First of all, aluminum, you should know the symbol of the periodic table. Aluminum is Al. Okay, so we put Al and is plus copper. Now copper is Cu, and you notice that you see a 2. That's telling us the charge is plus 2. Chloride, on the other hand, is Cl, and its charge is minus 1. And so we'll come back to this since we're already in the formula writing mode. Let's swap over here to aluminum chloride because this is where students kind of get stuff fuzzy, as far as writing the formula for something. So we have aluminum chloride. So aluminum is Al, okay, and it's aluminum, okay, so its charge is plus 3. So we'll put plus 3. Okay, and chloride is going to be Cl minus 1. Okay, Cl minus 1, Al plus 3, Cl minus 1. Okay, and then we have copper. You should know the symbol for copper is Cu. Okay, now what happens with these is that, remember, we have to switch them. I have to switch the 2 goes over here, the 1 actually disappears. So it's going to be CuCl2 for copper 2 chloride. Reacts to produce is an arrow, aluminum chloride. So there's a switch, 3 goes over here to the chlorine, 1, and that disappears. So we're going to put AlCl3. And I got those charges from the periodic table, but for Roman numerals, like the ones that are in the middle, the charge is going to come from the name that's inside the Roman numeral. So that's how you figure out that. And then copper is where it says plus, is plus, and then Cu. Okay, so now we got those things written out. Now we are going to have to balance it. So you have aluminum, 1 unit of aluminum atoms, that's a bubble. You have copper 2 chloride, so that's going to be Cu, but then you have Cl, okay, that's the other element, and you're going to, have 2 atoms of that. A lot of students think this is copper, carbon, and iodine. If it's iodine, it's going to be a capital I, okay? That's Cl, that's, chlorine. So don't think it's 3 different elements. Over here, aluminum and chloride. So you put Al and Cl. You have 3 atoms of chlorine connected to aluminum, so it's going to be written like that. And then copper is going to just be a single atom unit. So if you're looking at it, okay, we obviously see that we have an imbalance of chlorine atoms. Okay, whenever you have an odd number of the same element on both sides, you double what you have. So you double the odd one. So this is odd. So I'm going to double this. Now, if it's combustion, you double everything around the odd oxygen. But in anything else, you just double exactly the odd substance. So I'm just going to do another ACl3. Okay, and now that makes me have 6. So I have to come over here. I have units of 2. Okay, I need 3. So in order to get that 3, 2 times 3 will make it 6. So that means I need 3 units of this here. Cu, Cl, Cl, So that's what I did. Now by doing that, I changed the copper units. I have actually three copper atoms in this compound. You know, three different units of copper chloride, but basically three copper atoms. So in this, I need to show them as single units of copper atoms. Then over here, my aluminum's double because I have 2 units of aluminum chloride. So I need to show over here, aluminum is not combined. So it's going to be another group of just aluminum atoms. So it looks like I have 2 at the beginning, 2 at the end of the aluminum, 3 copper atoms at the beginning, 3 at the end, and 6 chlorines in all. So we notice that the aluminums start off by themselves, they're not connected to anything, but at the end, they're in combination with the chlorine atoms, and then 3 copper atoms get kicked out. So I would say that this is definitely a single replacement because these copper atoms, they kind of got kicked to the curb because the aluminums are now in a compound with the chlorines. This single replacement. Okay, so we put so we're going to say we have 2 units of aluminum atoms reacting with 3 units of copper 2 chloride compounds, which produces 2 units of aluminum chloride compounds and 3 units of copper atoms. Okay, so the last thing is what was oxidized and what was reduced. Okay, so you start off with aluminum as a neutral atom because it's not combined to anything. Okay, now in this compound, we're only concerned about the aluminum and chlorine because aluminum is 0 here and copper is 0 over here. So we don't care about the chlorines because they're not by themselves. But over here, we know to write the formula, the charge of copper was +2. And over here, to write the formula for aluminum chloride, the charge of aluminum was +3. Okay, so off to the side, or I'll just put it right here so everything's on the screen. We have aluminum, you have copper. So aluminum goes from 0 to +3, and copper goes from +2 to 0. So the question is, which one is going down? Okay, and as we look at it, if you go from positive to 0, you're going down. So the one that is reduced is the copper, and the one that was oxidized was the aluminum. Okay, so the copper was basically getting all of its electrons so it can pop out and be its own single element, which is what you saw when you did that part of the lab. You saw this brownish stuff that was copper being set free so it can be its own little element. So getting those electrons allowed for it to do that. So that is that. All right. So I left um, two two of them for you to do. Okay. Number 5 is very similar to number 1. Different elements, but it's the same process. And if you go through the process that I'll show you how to do this, you should be able to do it. Each of these is 5 points. 5 for correctly translating the sentence out into the element symbols and formulas. 5 for correctly balancing. Another 5 for identifying the type of reaction. Okay, what type is it? You can find the description right here or in your notes. And then 5 for correctly identifying what was oxidized, reduced. Okay, and don't do like some students. I don't know what they just went and copied one of these other ones. I don't know what people are thinking. You don't think I'm gonna see that? It's, it's, it's not too smart. Don't be like that. Number 6 is very similar to number 4. Different elements, but it's the same process. Oh, but with this one, when you have sulfate, this represents what's on the back of the periodic table. Sulfate comes from this. So is that one little step here is that you're having this polyatomic ion, but you're still switching. It's just only the negative number can move. Everything else is the same. But that's bonus. But anyway, I know I took a lot of time. I want to explain this. This is coming up again, man, on that final. So, you know, you should have enough insight in order to complete this assignment. All right, thanks.